Hello friends, welcome back to the lecture series on high voltage engineering. We are discussing measurement of high voltage and high current. In this particular lecture, I'll be discussing the numericals on high voltage and high current measurement techniques. So let us begin. With the first numerical, the numerical goes like this: a generating voltmeter. It means this numerical is asked on the generating voltmeter, has to be designed. So it means we have to design that voltmeter so that it can have a range from 20 to 200 kilovolt DC. If the indicating meter reads the minimum current of 2 microampere and maximum current of 25 microampere, what should be the capacitance of the generating voltmeter be? So we have to find out the value. Now, we have already seen in the discussion of generating voltmeter, the equation which we generally use is IRMS is equal to V into Cm into omega divided by root 2. Now, this V is applied voltage. As we know, it is proportional to the current applied voltage. Cm with the capacitance of the meter, and omega with the angular speed of the drive. Angular speed of the drive. This angular speed of the drive for a synchronous speed can be given by, like, omega can be written as twice pi. Synchronous speed is generally considered to be 1500 rpm. So let synchronous speed is 1500 rpm. So it is twice pi into 1500 divided by 60 for the conversion. So now the meter is reading 2 microampere. So therefore, for 2 microampere means 2 into 10 raised to power minus 6, with the voltage is 20 kilovolt. So 20 into 10 raised to power 3 volts multiplied by the capacitance of the meter multiplied by omega. So I just divide this term by root 2 and whole multiplied by twice pi into 1500 divided by 60. So if I rearrange the terms to get the value of Cm, and if I use the calculator for further calculations, then I'll get the value of this as, you can use calculator to get the value of Cm. So here, let us do the cross multiplication. Here you have 2 into 10 raised to power minus 6 multiplied by root 2 multiplied by 60 divided by 20 into 10 raised to power 3 multiplied by twice pi into 1500. So it comes out to be 0.9 into 10 raised to power minus 12 farad. As this is capacitance, therefore it is in farad. And if I convert this quantity into picofarad, then there is no need to write down 10 raised to power minus 12. So this is what the value of Cm. Okay. Now, by using same, the value of the current for 200 kilovolt can be calculated. So as this voltage is measured, so IRMS can be calculated. It is equal to. Now this is for 200 kilovolt. So I just write it here for 200 kilovolt. Over here that voltage was 20 kilovolt. So for 200 kilovolt, IRMS is equal to. Now again, it is 200 into 10 to the power 3 into Cm, which is 0.9 into 10 to the power minus 12 divided by root 2 into twice pi 1500 divided by 60. And the value of this IRMS, it comes out to be. So let us again use calculator for doing the calculations. 200 into 10 to the power 3 multiplied by 0.9 into 10 to the power minus 12 multiplied by twice multiplied by pi multiplied by 1500 divided by root 2 into 60. And this gives you a value of 19.99 into 10 raised to power minus 6. Now this is current, hence its unit is ampere. So 19.9 can be written as nearly equal to 20, and 10 to the power minus 6 can be written as micro ampere. So that is what the value of RMS current. So this meter can do the measurement of 20 microampere for the said voltage. Means the reading on the meter will be 20 microampere for a voltage range of 200 kilovolt. So this is your first numerical. This was asked on generating voltmeter. Now, let us take another numerical. This particular numerical is asked on a peak reading voltmeter. So it means if the name of the meter written as voltmeter, it means that it is the numerical on the measurement of high voltage and high current. So we have to design a peak reading voltmeter so that that voltmeter can read the peak value of the pulse or waveform along with a suitable microammeter such that it will be able to read voltages up to 100 kilovolt peak. The capacitance potential divider available is of the ratio 1000:1. So let us start with the solution. Here the numerical is on peak reading voltmeter. So we already have the equation. It is written while discussing the numerical. So few things that we have to consider or assume. So assume microammeter means the meter which we are using that definitely have certain range. So this microammeter has a range of 0 to 10 microampere. So while connecting this kind of ammeter, 0 becomes the common point and 10 ampere is the maximum scale that can be shown on the meter. So the voltage which is available at the arm, that is capacitor arm, that can be calculated as we have a peak value of the voltage, that is 100 kilovolt. It means 100 into 10 to the power 3 divided by the ratio which is given there, that is capacitance potential divider ratio. So it means it is 1000 by 1. So it means it is 1000. So 1000 by 1, right? So therefore, what we get is 100 volt peak. Means what is the value of the voltage which is available across a capacitor is 100 volt. That is peak value. That belongs to peak value, as the voltmeter is a peak value measurement. Now, the series resistance R, which is in series with microammeter, that can be calculated as, so R is equal to voltage, that is 100 volt, which we have calculated, divided by current. So here the formula which we are using is resistance is equal to voltage upon peak value of current. So voltage is 100 volt, which we have calculated across the capacitor branch, divided by the current. Now that current which we have already assumed is say 10 microampere. So it means 10 into 10 to the power minus 6. So the value of that resistance is to be 10 to the power 7 ohms. This 0 get cancelled. You have 10 into 10 to the power 6. Or in other words, you can write down as 10 mega ohms. What is the value for the resistance R? Now, we know that time constant tau, it is given by R into C. And let us assume that it is having a range from say 1 to 10 seconds. It is 1 to 10 seconds. Now, let us assume this value of the tau is 10 seconds. So therefore, what we can do is C can be calculated, which is on left hand side. So 10 be the maximum limit divided by R. So range of the tau is 1 to 10 seconds. C can be calculated as 10 upon R. So 10 upon 10 mega ohms means 10 to the power 7 ohms. Now again, this 10 get cancelled. You get 10 to the power minus 6 farad, as this is your capacitor. And therefore, the value of that capacitor is 1 microfarad. 1 microfarad. Hence, therefore, the value of the resistance is 10 mega ohms in the circuit, and the value of the capacitance is 1 microfarad. So this way you can design the peak reading voltmeter with the microammeter connected in the network, and that will read the voltage up to 100 kilovolt peak. Okay, so that's all with this particular numerical. Now let us discuss next numerical. This is the simple numerical where you have to calculate the correction factor for atmospheric condition. Correction factor is generally given by the equation. So I just write first solution. This correction factor, it means this particular numerical is from the sphere gap, where delta is the correction factor. Delta is the correction factor, which is given by 3.92 into B. Here, that B be the pressure, right? Divided by 273 plus T. It is equal to, now 3.92 multiplied by the pressure which is mentioned here is 750 mmHg. So this pressure B, it is generally written in centimeter. So therefore 750 millimeter can be represented as 75 centimeter of Hg. So this B pressure is 75 centimeter divided by 273 plus the temperature which is mentioned here is 27 degree Celsius. So therefore the value which we get after doing calculation is, so let us use again the calculator, 3.92 multiplied by 75 divided by 273 plus 27. So this value is, delta correction factor is 0.98. Delta is 0.98. So this is called as air density correction factor. Air density correction factor, which is equal to 0.98. Which is equal to 0.98. Okay, so that's all with this numerical. Let us consider another numerical. Here the numerical goes like this. Here the numerical goes like this. Determine the breakdown voltage for air gap of 2 mm and 15 mm length. So there are two air gaps which are given. Under uniform field and standard atmospheric conditions. Also determine the voltage if the atmospheric pressure is 750 mmHg with a temperature of 35 degrees Celsius. So if this is given, it means we have to find out the air density correction factor. Like in previous case, we have calculated. So air density correction factor. In last numerical, we have calculated this factor. So I just write it here, air density correction factor, that is also a required. Okay. So we have the formula. Let us use that formula, which is given by, again, this is the numerical on sphere gap, as here that air is mentioned, breakdown voltage is mentioned, and so on with the air gaps and all. So therefore, the equation which is given, which we discussed, is this one. VB is equal to 24.22 into S. S be the air gap plus 6.08 into root of S. Now for S equal to 2 mm. Again, this distance is in centimeter. So therefore it is 0.2 centimeter. Implies VB is equal to 24.22 into 0.2 plus 6.08 into root of 0.2. Root of 0.2. And if we do the calculation, the value of the breakdown voltage comes out to be, let us use calculator again, 24.22 into 0.2 plus 6.08 into root of 0.2. So this is 7.56 kilovolt. Now another gap which is mentioned is S is equal to 15 mm, 15 millimeter. So for 15 millimeter, its centimeter value is 1.5 centimeters, and implies VB, again by using same formula, 24.22 into 1.5 plus 6.08 into root of 1.5. So this comes out to be, just replace in calculator, zero point 0.2 by 1.5, as you have already done the calculations. So therefore you get that as 43.777 kilovolt. So this is what the value. Now we have to follow the further steps, because we have to find out the determine the voltage if the pressure and the temperature is mentioned. So here you need to find the air density correction factor, that is given by delta, and the formula which we already discussed is 3.92 into B divided by 273 plus T. Now it is 3.92 multiplied by B, that is pressure. Now that pressure is again in centimeter, so 750 mm. It is B, right? But that is in mm. So this can be written as 75 centimeter. 75 centimeter. So it is 75 centimeter divided by 273 plus temperature 35 degree Celsius. So with this, you get the value for delta, which comes out to be 0.9545. Now, if this is what the value of delta, or in other words, in few books it is written as K with a correction factor, right? So therefore, the voltage can be calculated as K multiplied by the breakdown voltage we are calculating. So this K is 0.9545 multiplied by breakdown voltage is 7.56 kilovolt. As this is in kilovolt, so therefore the quantity which we get is, let us do the multiplication. So 7.56 multiplied by 0.9545. So it comes out to be 7.216 kilovolt. For another distance with the same correction factor, so 0.9545 multiplied by 43.777 kilovolt, and this value comes out to be 41.78 kilovolt. So these are the values of the voltages which we have to found. So this is that voltage for two different distances. Okay, so that's all with this numerical. So in this lecture, we are discussing these numericals. Hope you understood the concept and the method of getting the solution with the formula. So thank you so much, guys.